Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. My name is MUHAMAD Syazwan bin MAZLAN and my supervisor name is Prof. T.S. Dr. Ahmad Yusari bin Bani Hashim, and I will present my bachelor degree project 2, which is development of a feedback control system of a single manipulator controlled by a single blade rotor propeller using GPID control approach. So the problem statement of this project is that this project will be focused on the boom gate system, which means our project will be applied the single rotor propeller, and the single rotor propeller will be applied to the boom gate system. This is because the boom gate required high torque during open and closed movement, and based on the boom gate system from Malaysian company, the boom gate operate at 240 volt from open and closed movement. This project is just feasibility study to check whether the single rotor propeller can give an impact and efficiency to the boom gate system. The single rotor propeller will be just an assistive device to the system and not totally replace the whole system. As I mentioned earlier, this assistive device not totally replace the whole system, which means that it will be investigated from horizontal to open movement by also applying the GPID control approach in prototype scale. Using GPID control approach means that using one of the various type of method to find the PID value. To find the PID value method, there has many methods such as the Ziegler-Nichols method, Cohen-Coe method, genetic algorithm method. So in this project, we'll be just using one type of PID method to find the value. The objective of this project is that the first one is to study the application of PID on the boom gate system. We study through the PID value we inserted to the system, whether the PID value can give efficiency to the system. The second one is that to develop an assisted boom gate. In this project, we create a model in a prototype scale rather than use the actual scale of the boom gate system due to cost. The third one is to evaluate the performance of the assisted boom gate. This will evaluate using through the observation and reaction of the model prototype, and also we evaluate through the serial monitor data from the Arduino. So the methodology of this project will be start by the conceptual design, and then we will proceed to the model and scale down of the project, and then we will proceed to the selection build of the material of our project if the material is suitable, and then we fabricate the project, and then we can go through the programmable coding part, which is will be insert and test and simulate various PID value, set point, and also minimum and max RPM of the motor. Since the method we use in this project is trial and error method. And then for the finalized system specification is that we finalize the PID value, set point value, and also the minimum and maximum RPM of the motor. And then we see the behavior and reaction of the model system, and the result will be concluded in the chapter 4. This is the conceptual design of the boom gate system. For the design A, the single rotor propeller will be placed further away from the pivot, which is the degree freedom of the boom gate system, while the design B, the single rotor propeller will be placed near to the control unit of the boom gate system. There is the advantages and disadvantages from this both design. The design A can get high torque than the design B. We also sketch the design B because the safety consideration. When we talk about the boom gate system, it will be interact to the users, especially a car, to go pass through the boom gate barrier. But to the design B, the single rotor propeller on the design B must create the high torque same as the design A, which means high forces and produce high electricity. We don't want that, so we choose the design A rather than design B. This is the calculation, the amount of torque between design A and design B. From this calculation, we can conclude that the design A produces more torque than the design B. This is the specification of the boom gate arm. We choose 4 meter arm, which is weight of the 5 kg, and also we find the motor that can actually lifted up the 5 kg of the boom gate arm, which at the throttle at 62% and valve, it can increase the boom gate arm, but this motor cannot be directly choose or input to the system because there is no PID value or efficiency that in this specification. Because if we use just throttle to ramp up the gate, the reaction will be aggressive, and also maybe the current will be increased. So with PID value, maybe the power can be decreased and the reaction of the ramp arm of the boom gate arm will be gently. So this is part of the model and scale part. The actual length of the boom barrier hollow bar length from 4000 mm will be scaled down to the 400 mm, and then the actual weight of the motor also will be scaled down to 1/10, which is 77.2 gram. This is because the size of the motor must be fit to the new dimension of the boom barrier hollow bar length. For the selection of the components from my prototype, I use this ECAC calculator online to find the suitable components for my prototype. Based on this calculator also, I can see the thrust produced based on the model weight of my prototype. This is the bill of material for this project. The total cost to build this model prototype is about RM344.38. This is the 3D model of the prototype. There is 15 components that are used in this model. This is the animation of the model system. The boom barrier length of the boom barrier bar will be go up to the desired angle that we want. This is the schematic diagram of this prototype. From the motor, we use BLDC motor will be connect to the ESC, and then the lithium polymer battery will be connect also to the system to power up the system, and Arduino Uno will be act as a controller to the system to give the instruction, and the MPU6050 also will be applied to the system. The MPU is a critical part for this project to find the desired angle of the boom area bar angle that we want. This is the full product of the project when after fabricate. In this part test and simulate, we set the set point is the desired angle that we want, and then the angle will go through the Arduino controller, and the controller will power up the motor in a pulse width modulation value, but we don't know how much the RPM of the motor for the angle value. So the sensor MPU6050 will send a feedback signal back to the system for the correction, and then we know the system actual RPM value for the actual angle. And this is the final system specification for my prototype. This is the PID value that fixed for the horizontal part and also for the lifted part. So this is the result of our experiment. This is the for horizontal part. As you can see that the motor stabilized at the position, the desired angle that we insert. And this is for the lifted part. As you guys can see that this is the motor lifted up to the desired angle that we want. So, discussion part, difference value of PID between both systems due to the thrust produced is also different. This is related to resultant force, because in kinematics, it deals forces in axis. So, if the part was horizontal, the system does not have x-axis force, it only have y-axis force, and also the opposing force, which is thrust. But in this case, the error angle has become resultant force, which is component x and y, and thrust of the system produced not directly vertical, it actually produced constraint to an angular, which means it has become 2 degrees of freedom but constrained to 1 degree, so it cannot be treated equally. So for the lifted part, even though the minimum pulse width modulation value insert is low, the desired position angle set point is achieved to the PID calculation in the system. This can be observed based on the RPM motor when lifted part. The RPM motor minimum is 600, but it has achieved to the desired angle that we want. For the horizontal part, it shows that PID value can make the system stabilize. And then there's also disadvantage in this project, which means when the voltage of the battery is dropped, it affects the whole performance. This means that the PID value, set point value, speed must be changed and interrupt according to the actual voltage value. And the below is the graph from the data from serial monitor that comes up from the Arduino. It seems that the graph is stable based on the angle and the RPM of the motor that has been produced. For the conclusion of this project, the PID value can increase the performance and efficiency of the system. Based on this two video, the arm bar generally achieved to the desired angle. If we use just throttle to ramp up the system, the arm bar will produce aggressively reaction compared to the PID effectiveness. After that, with suitable PID value, desired duration can be achieved even though with less amount of RPM of the motor. Based on the lifted part of the video, the minimum RPM of the motor is just 600, but it can achieve to the 70 degree of the desired angle. And then, based on the result also, the motor and propeller can be applied to the real system using suitable PID value. For the suggestion of this project, I suggest that we change the LiPo battery to fixed power source to obtain the fixed amounts of voltage. And then I suggest that the design, the safety aspect for the motor and propeller, since it will be applied on the boom gate system, which will be interact to the user. And then the third one, I suggest that we apply the application for both movement, which is open and close. Thank you.